Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
Welcome to the Uptime Wind Energy Podcast Spotlight. I'm your host, Alan Hall, along with my co-host, Joel Saxum. Today we have two experts pioneering innovative wind turbine inspection methods. René Harendt is the CTO of Romotioncam, whose patented technology enables high-res photography of operating wind turbines. And Michael Stamm from Germany's Federal Institute for Materials Research and Testing, who specializes in thermographic inspection methods for wind turbines. Together, they're combining visual and infrared imaging to revolutionize how we detect early-stage blade issues. René and Michael, welcome to the Uptime Wind Energy Podcast Spotlight.
Thank you.
Well, we have seen Romotioncam a number of times, and the technology is really good, René. I like it because the turbine continues to operate as you take high-quality images. The technology has evolved quite a bit from the last time I have seen it. Do you want to explain where you're at with Romotioncam today?
So at the moment, we actually build up a fleet to scale up and to provide it to a bigger market. And I actually have a new prototype with a bigger focal length. So the actual system has a 500 millimeter focal length. The new system has an 840 millimeter focal length. So that means that we can, even on higher turbines and bigger blades, because this is related to our distance to the turbines, we can provide GSDs like 0.06 centimeter per pixel. So something like up to 0.08 centimeter per pixel.
So in that kind of imaging resolution, you can detect all kinds of blade abnormalities.
Yes, even little hair cracks and stuff like this. Well, we can do them.
Yeah, because you're approaching what a drone can do, right? That's, even a couple of years ago, 2 millimeters per pixel, 3 millimeters per pixel is kind of normal. But now that 1 millimeter per pixel, a lot of times you'll see that in an RFP, right? When someone puts out, hey, we want inspections, and they put it out to the market, 1 millimeter per pixel will be the standard. But you guys are offering this without actually having to stop the turbine, so your value add goes through the roof because you're keeping that production going.
That's true. And if you think about it, that sometimes we at a distance of 160 meters, something like this, and can provide that kind of GSD. So sometimes that's amazing, yeah.
So maybe, René, for those uninitiated who are not familiar with Romotioncam, what are the fundamentals here? How does this system work?
The easiest way is to go to our website and watch the video. I think this can explain everything. So go to romotioncam.com and watch the video. But I try to explain it a little bit. So the key thing is that we're using one camera to track the whole rotor and the blades, and a special tracking technology behind it, which is also patented, can detect the wingtips and can calculate the rotation speed and the position of the turbine and stuff like this, and then calculate it in the kind of movement data for a pan tilt head. And we have the camera integrated into a pan tilt head that can follow the blade all the time. So that means even on high tip speeds, we can follow the tip. It's like two fast cars driving next to each other. You literally can shake hands, and this allows us for the camera to use low shutter speeds, and we can deal also with low light condition because we don't have to put the ISO too high and stuff like this. So we can eliminate some photographic issues you would normally have if you're trying to freeze some motions. Yeah.
Now, the majority of the work you do is in Europe, but you were in the United States for a short while. Can you explain what kind of work you're doing in Europe at the minute?
So, we are subcontractors. So we have a frame contract with RWE. So we're running out some inspections, but we want to open the market a little bit more. So there is a plan for next year to open up an entity in the US. Yeah. To be honest, at the moment, in our political situation, so we have to take a look what happened, and if it's I mean, it's not that easy for us, to come over to the US. It's not that we just saying, okay, we want to open an entity. There's a lot of paperwork we try to clarify now. But at the moment, the political situation is a little bit, we don't really know. I think we have to wait. It could be more complicated, maybe more easier. Let's see what happens. So, but the goal is to come to the US and open an entity there as well.
And the latest technology, and we talked several weeks ago now, that Romotioncam has been involved with, is on the thermal imaging side. And the first time I heard about this was probably a year ago when we were in Amsterdam at one of the Blade conferences, and I was just blown away. Like, you can take thermal imaging from a Romotioncam on the ground. That's amazing. That's amazing. And then it was described what that camera and that technology could do. And this is where Michael comes in, where Michael is our thermal imaging expert. And Michael, can you describe where you work at, just to make sure I get the right label on it?
Hi, I'm Michael. I work at a research institute, so I'm definitely on the research side of this technology. And we are performing thermal imaging of operating wind turbines from the ground. And this is actually also where we met with Romotioncam, because it's really important for a proper interpretation of our thermal images. We really needed high resolutional visual images. And then we were just looking for somebody providing this simultaneously from the same point we were looking at. And then that was like the match with the Romotioncam. And now we just like had a big measurement campaign where we tried to benchmark what is possible. Where are we? We are working on this, like BAM is working on this since something like 7 years. And I know even when I have discussions with experts from the field, I know that even 15 years ago, people were already talking about thermal inspection of rotor blades. So it's like not really inherently new. I just say like things develop, cameras develop, understanding develops, simulation develop. So we are trying to get it where it's really useful for the industry.
Traditionally, we know in the wind turbine world, visual inspections via drone, Romotioncam, as you guys are doing, is fantastic. Pairing that with thermal, what exactly can you guys see, or are you trying to image, and what value are you trying to bring to the inspections?
I want to distinguish two physical phenomena, and I think it's really important to get this once clarified, and then we can go to the fun part. But there are different physical phenomena that give you a thermal signature on your blade. And you have to distinguish these signatures. And one of the signatures is flow, airflow. Turbulent flow has a higher heat exchange between air and blade than laminar flow. So you see the difference between laminar and turbulent flow, which, for example, helps you to characterize leading edge defects, which result in turbulent flow patterns. That's the first point. And the second point is completely independent of the flow. It's really like the inner structure of the blade. It's like just a different thing to look into the things. The sun is rising, you see the entire blade gets warm, and wherever there is, for example, foam, balsa, air, it gets warmer faster. Why? Because you just don't have that high heat capacity. Having a big part of CFRP of a few centimeters, it takes time to heat this up. And then this honeycomb structure is warm already. And that's like the second physical phenomena. So you really have to distinguish. And then definitely you look for the application in this case. For example, with Romotioncam, we were really looking for this flow visualization.
So, and you also can look for, and I think this is an important one, friction creates heat. And or a lack of friction can create a colder spot. And so it's more like you're looking on the blade. You're not looking for a specific temperature, right? We're not looking for, I want to see the spot that's, 21.2 degrees Celsius. I want to see the spots that are 21.2 and 21.0 in between the two to see the differences. Because if you can find a delta within this homogeneous blade structure, then you might be able to pinpoint something. Then if it's friction, you might be seeing a crack, or you might be seeing a disbond in the shear web, where that shear web is moving. As the blade moves, it creates a little bit of friction, creates a little bit of heat as things move on. So is that part of one of the goals and one of the things that you guys can work with here? And how's that working?
That's physics part number 3.
Okay, I'm ahead of the conversation. Sorry.
At this point, best greetings to the DTU Aquata Go project from Shaoshen. They are focusing exactly on this. It's a third way to look at things. And here I know that 15 years ago, people already started to operate the turbine, stop it, and do the inspection. What do you get then? You do not have the flow anymore because you stop the turbine, but you still have the heat from the friction. So that's one way of doing things. Before meeting Romotioncam, we were really focusing on these inner defects. The inner defects, the delamination, which you see not due to friction, you see it due to the air in your system, which is almost like a pillow. It's like an isolator. Air is a perfect isolator. So when you have, for example, a delamination between the spar and the web, you might see it. If you have a delamination at the trailing edge, you see it very well. Way before it's actually open. Before it opens up, you already see that there's like a delamination. We were focusing on this. So you see that it's like you always use the thermal camera. You always look at the temperature of your blade, but you really have to understand to what look for under which conditions. That's the main message.
So then thermal imaging becomes extremely valuable with Romotioncam, because now you can, in theory, see structural issues. You can see thermal changes that way, but you can also see aerodynamic differences between the ideal blade and what you actually have without stopping the turbine. So it doesn't take any lockout tag out. No one's climbing the turbine. Everything is remote from the turbine. And the big problem I think that exists today is a lot of operators know they have leading edge erosion or some sort of aerodynamic problem, but it's very difficult to visualize that. You just can't walk up to a blade and say to yourself, well, I know this blade is losing 3%. I can't do that today. It's too much to process. And then I have to do a CFD analysis or some sort of interpretive engineering effort to determine roughly what that loss is. You can walk up there today, put a thermal camera, Romotion camera up there, and say, this is how much energy is being wasted in turbulence. This is where your problems are. These are the areas that you need to focus on instantaneously almost.
Exactly, and this is what we with the Romotioncam. So our next step is to integrate both cameras in one system, so that we can take a one shot the thermal images, and on that part we also have to separate it a little bit. So we have to see the TTP patterns, so the turbulent flow patterns, the turbulent flow patterns. This is something we can deliver right in one shot with our normal blade inspection, with the normal visual inspections. Yeah, we can lay over the images and we can see, okay, which damage causes from turbulences. And we also, sometimes we see also turbulences that is not related to damages we're seeing. So there's something more we don't know yet. Yeah. So, and this is something we can carry out as a normal inspection. And then we are trying with the same system, but in another way of doing it. Yeah. And this is the more challenging part, what we're trying to do. Yeah. And in our next project. So to figure out what conditions we need to look into the blades, because it's not about to seeing something is. We have to make sure when we're coming and doing this kind of blade inspections, also that we want to look inside a blade. We want to make sure that when we don't see anything, then there is nothing. And that's the challenge. Because it might be that on the one day, and everybody can buy a camera and trying to do this. And it could be that you can come to the turbine and on the one day you're seeing something, on the next day you see nothing. So, and in the end of the day, when you see nothing, what is it? Was it a bad day? What is the wrong condition or something like this? And this is the challenge, yeah, we will try to solve.
when you're really looking at, scientific grade thermal images, there's a lot you can learn from them, but there's also a lot you need to understand as an expert, like Michael, like yourself, to know that, if the sun is hitting this blade surface at a certain angle, how does that possibly interfere with the things that we're trying to get from it? And if today is cloudy or, it's a cold morning versus a hot morning, those kind of things, that's where you guys come into play.
A good colleague of mine, he always says, you do not only need the fast car to win the race. You also need the driver, you need the maintenance, you need the ground station. And it's exactly this, you need more than just a good camera. Yes, with Romotioncam, we are absolutely on the edge. Like, this system will be really, really cool. And still, what we are working on are, for example, finite element simulations. You simulate your structure, you simulate your weather conditions, and then you get an idea of, am I actually possible to see on Tuesday morning these defects? Or is it the wrong weather conditions? So, like, to exclude these false negatives, false positives, this we are trying to do with simulations. And then you have to combine all this knowledge. You have to know your blades. And then you get way more than the turbulence patterns. The turbulence patterns you almost see in almost all conditions. It's like a nice added value. But to look into your blade 10 centimeters deep, you really have to know what you're doing. And then you must be sure that if you do not see anything, you don't have a crack. Otherwise, the value is gone.
Michael, you've done a number of tests. You've done about 30 turbines worth with the thermal imaging camera, and that data is available. You can just go look on the internet. You can find it. Those images with the Romotioncam are really, really good. It is shocking to see those images because it's eye-opening. Like, oh my gosh, that leading edge defect is causing turbulence. There it is. It's remarkable how fast that works. How good is that technology? Like, do you expect this to just operators to start implementing this as just a sanity check? Because that's what I would see, particularly because Romotioncam doesn't involve shutting off the turbine. There's a whole cold season here where the turbines are spinning and no one wants to stop them. The wintertime's a great time to make power, but you could also learn so much about your turbines and how they're really performing in a short amount of time. Is that the value add here?
Yeah, from my perspective, I mean, to go back to the data set we're providing, it does not really represent our normal inspection data, because we had to find a compromise with Michael from the BAM and with their system. And this is where also the idea was born, to really make it and to really have different angles, different views on the blade, even with thermal and with the visual images. There's no way around than putting two cameras in one system. Yeah, and let it spin. And of course, the added value is that we doing it with no downtime, so we are completely invisible. We just tell me, okay, what's the size of your turbine, what's the blade length, and where is the turbine? Can I access this by alone, or do I have to make is there a fence or something like this? I mean, in Europe, normally the turbines are open. You can access that. So we are pretty much invisible. So we're just going there, taking the images, and the next contact you will have with me is the report. Yeah. And you don't know when we have been there, when we did it, something like this. So this is our normal procedure. So there's no communication anymore with our clients. We don't need a technician in field. We don't have to plan in advance. You just give us the locations. We're checking everything independently. We see if everything is accessible, and then we planning to capture the data completely independent by ourselves. Yeah. So that's the thing. And of course, the goal for the next year is to put both cameras in one system so that we can deliver in a report the added value, that we can at least show you the turbulences. I don't think that you can really say you're losing this percentage of efficiency, but we can give you an overall view compared maybe to the normal flows that we can see, okay, these turbine or these blades, if we compare it with other ones, is a little bit critical. So we can give the clients a little bit another viewpoint on damages. And maybe it helps a little bit to define some repair times, because it's not only related on safety reasons anymore. It's also, there comes another point here, and that's the efficiency. Yeah. And it might be that because of the efficiency loss, it's cheaper to repair it now.
I think the important thing to focus on here is that the Romotioncam system and the advances that you guys have done, you just talked about an 840 millimeter lens coming and the 1 millimeter, ground basically per pixel on the blade. The ability to do that and not interrupt field operations. I mean, Alan and I were just in the field last week. We talked with multiple places where they're like, we've got so much going on. Now we're talking the US for the most part here, right? Where there's 100, 120, 150 turbines in a wind farm. There's so many activities going on daily on those things, like to find the guy for lotto, to get another technician to help you, escort you around the field and do all these different things. That takes away from other things that need to be done on the wind farm. And site supervisors, it's a pain in the butt for them. They're like, oh, the inspection, or the inspection guys are here, or this or there, or this or here. The fact that you guys can show up on site, do your safety orientation, get a map of the field, and then just say, see you later. We're not going to affect your production, and we're going to deliver you results without basically bothering you in the field. That, to me, as a site supervisor, would make me smile from ear to ear. And then now you're getting to the point where, hey, we're also adding this thermal technology. We're doing other things that are value add in the field. So when you're out there, you're collecting more data, you're delivering more insights, and you're not bothering anybody basically during your operation. So I think this is something that definitely, if you haven't looked into Romotioncam, you need to give these guys a call if you're if you're looking for inspections.
The information from this is remarkable, and I encourage everybody to go online and look for Michael's data, and we'll put the link in the show notes so you can see this stuff. It's truly revolutionary. I know we use that term a lot in the wind energy industry, but to me, engineer, this is magic. And I have to commend both of you. Combining these two technologies, I'm sure, was not easy. And I know there's a lot of computer software behind the scenes to make all these pictures possible, but it is truly remarkable. And so, René, obviously a lot of people are going to be interested in Romotioncam. How do they reach out to you? How do they connect?
I think they can just go on our website and they can connect with on LinkedIn, of course. Just connect on LinkedIn, and we're trying to keep you updated also with the progress of developments and stuff like this.
So just visit Romotioncam.com. And Michael, you're a researcher, one of those great scientists over in Germany. How do they connect with you?
I'm on LinkedIn, and we have like a quite nice webpage, I must say, for a governmental institution. So, and there you also find some links. We work the scientific way. So what we do, we put down in scientific papers where it's described in detail. And these are online. These are available, and you can just check them out. You check out the data, and then give me a call, and we'll see if we come together. Would be happy to propose this really new or revolutionary technology to some others, also in the US, by the way.
Yes. Yeah, you're welcome in the US anytime. René and Michael, thank you so much for being on the podcast. Truly remarkable technology.
Thank you.
Thanks for the invitation.